Hello, I am back. My name is Benjamin Chesser. And to whom it may concern, this is a presentation overview 2 for Math 345. So we have a few civilizations to get to, and we're starting in ancient China. And there has been civilizations in ancient China since about 1600 BC. Inscription in bones is where we find the earliest knowledge of their number system and what they were working with. Interestingly enough, they were the first civilization to invent paper and iron. However, their governmental system wasn't set up in such a way that it profited much from it. They tended to be heavily regulated and highly centralized bureaucratic state when it was unified in 221 BC. So the math of ancient China, they were the first civilization that we see a base 10 number system, similar to the one that we have, the same one that we have today. Their geometry was generally practical. However, important theoretical principles were developed. Some of these were like calculating the area and volume of different geometrical figures. For example, the Chinese work called Nine Chapters was composed over several generations from different mathematicians. And it gives the correct formula for the volume of a pyramid and a lot of other geometrical figures. They also were interested in solving systems of linear equations. They had two methods to do this. The first one was called the double false position, where you basically guess possible solutions and then adjust to get the correct answer. The second method that they used to solve linear equations looks identical to the method that we have today, which is the Gaussian elimination. And they also had a fun way to solve system of linear congruences, which is what we know today as the Chinese remainder theorem, which is pretty interesting theorem. The next civilization we will cover is India, ancient India. Evidence of math in India goes back as far as 2000 BC. Interestingly enough, they used, or I'll get to that in a second, but they were a little bit about the civilization. They were an oral civilization. They passed down their literature and information and traditions orally. Through lengthy verses called Vedas. They are mostly concerned with spiritual matters, so like sacrificial practices, traditions having to do with religion. Their activities such as fortifications, administrative centralization, and large-scale irrigation, that rhymes, made mathematics necessary, so they needed to solve problems with having a high functioning civilization taking care of a lot of people. So there was a number of mathematicians that contributed during this period in India. So their number system resembles China's number system. So they were base 10, like us today. Mathematicians included I'm going to pronounce none of these guys correctly, but Brahmagupta, Aryabhata, Bhaskara the first, Bhaskara the second, and Mahavira. So those were some mathematicians during that period. So Mahavira composed the first Sanskrit textbook entirely devoted to mathematics. Aryabhata introduced methods for calculating squares and cube roots. The picture that I have on the slide is of Brahmagupta, and he did a lot of interesting work. He used math to prove the Earth was round. and he calculated the solar year within 6 hours. But his most notable contribution was his work with the zero. Pre-Brahmagupta, pre that guy, they didn't have the number zero as we have it today. They usually use a dash or just a space. But he was the first one to treat zero as an integer. So he concluded things like if you were to add or subtract zero to any integer, it would leave that integer unchanged. So things that we take for granted today, but he came up with. So thank you, Brahmagupta. Madhava did work in astronomy and mathematics. He was able to devise a system that estimated the position of the moon for every 30 minutes. And he also did work with infinite series and was able to estimate sine x using infinite series, among other things. So the next civilization is going to be ancient Islam. So it began around like 570 AD. It was under the authority of the self-proclaimed prophet Muhammad. And they gained power and influence through military conquest. And I have a picture of Muhammad on there. That's the good-looking man on the slide. Their mathematics flourished. They viewed mathematics as mandated by God, mathematical inquiry. So a lot of the progress in that area was influenced by religion. They improved India's decimal system and formed what we have today. And their mathematicians included Al-Khwarizmi, Al-Uqlidsi, and Al-Samawal. And their most important contributions was in the field of algebra, and that was from Al-Khwarizmi's work, and the title of his work was The Condensed Book on the Calculations of Al-Jabr and Al-Muqabala. And we reference this work every time we solve an equation because Al-Jabr can be translated restoring, which basically refers to when we have a negative quantity on one side of the equal sign and we add it to we add that quantity to both sides. We are restoring, or Al-Jabr, and Al-Muqabala can be translated as comparing, and it refers to when we have a or it refers to the reduction of a positive term by subtracting equal amounts from both sides of the equation. Which I have an equation here, but I won't read it out loud because it just sounds confusing. Next civilization is medieval Europe. So this is after the fall of Rome in 476 AD. In Europe, divided into many numerous factions that were kind of warring with each other. I said that this was mislabeled as the Dark Ages just because there wasn't a lot of literature that was produced. Because there wasn't a ruling class, there wasn't a group of people that were free to write. A lot of the people were mainly focused on surviving and agriculture and doing things that were more practical rather than academic. There was a heavier reliance on non-slave labor, probably because they didn't have a centralized government and a lot of military conquest giving them slaves. So there was a lot of reliance on non-slave labor, which led to a lot of inventions from that time, which I thought was super cool. There was a lot of things invented, and all of them were basically related to agriculture and practical matters. For example, the horseshoe was invented in this era. Pre-medieval Europe, they used horses and ox to till fields and such, but they had the strap around their neck, so they couldn't pull a lot of weight without being choked. In this era, they invented the harness where it goes around the chest of the horse, so that's pretty interesting as well. Different agricultural tools, modern wheelbarrows, and wind-powered mills were all invented in this era. So math of medieval Europe. Let's see. So there's an emphasis on translating older documents. So works like Euclid's Elements, Algebra of Al-Khwarizmi, Ptolemy's Almagest, many of Archimedes' works, and plenty of other famous texts. So there's a lot of translations being done from ancient languages into Latin, into whatever they were speaking. A very important mathematician of that era was Abraham Bar Haya. So he's credited for bringing the first trigonometric table to Europe. Other mathematicians include Leonardo of Pisa, Richard of Wallingford, and Levi ben Gerson. In the mathematics of that time, we saw new developments in spherical and plane trigonometry and in the theory of combinatorics, thanks to the work of Levi ben Gerson, like I said, and many others. So that is a quick overview of a few ancient civilizations from period 2. Thank you for joining me on this journey, and I love you guys. All right, bye.